Chemistry is the scientific study of the properties, composition, structure, and changes of matter. It explores how substances interact with each other and the energy involved in these processes. Chemistry helps explain how substances form new compounds or break down, why they have certain physical properties, and how they can be transformed. Often called the central science, chemistry connects physics with other natural sciences like biology and geology. The beginning of chemistry, from alchemy to modern science, ancient origins. The roots of chemistry can be traced back to ancient civilizations. Early people practiced alchemy, a proto-scientific discipline focused on transforming materials, often with mystical or spiritual goals like turning base metals into gold or discovering the elixir of life. Early Egyptians, Greeks, and Chinese contributed to chemical knowledge, studying metallurgy, medicine, and dyeing. Greek philosophy. The first theories of matter came from Greek philosophers like Democritus, who introduced the idea of atoms, and Aristotle, who believed everything was made of four elements: earth, air, fire, and water. While not entirely accurate, these ideas set the stage for future discoveries. Islamic Golden Age. During the Middle Ages, the Islamic world preserved and expanded upon earlier Greek ideas. Jabir ibn Hayyan, Geber, is often considered the father of chemistry. He introduced the experimental method and made significant discoveries in alchemy and metallurgy, focusing on the purification of substances. The Age of Alchemy. Alchemy was practiced extensively in Europe during the Middle Ages and Renaissance. Alchemists laid the groundwork for modern chemistry through experiments with substances, even if they were often shrouded in mystical goals. Paracelsus, a Swiss alchemist, applied chemical principles to medicine, advancing the field of pharmacology. The birth of modern chemistry. In the 17th century, chemistry began to emerge as a true science. Robert Boyle, often called the father of modern chemistry, emphasized the importance of observation and experimentation. His work on gases led to Boyle's law, which describes the relationship between the pressure and volume of gases. Boyle also rejected the classical elements theory, promoting the idea that matter is composed of corpuscles, early idea of atoms. The Chemical Revolution. The 18th century saw chemistry move toward a more formal and systematic science. Antoine Lavoisier, a French chemist, is credited with revolutionizing the field. He defined the law of conservation of mass. Matter is neither created nor destroyed in chemical reactions, named oxygen and hydrogen, and debunked the ancient phlogiston theory of combustion. Lavoisier's work marked the beginning of modern chemical nomenclature and quantitative experiments. 19th century discoveries. The 19th century was a period of rapid advancements in chemistry. Dmitri Mendeleev developed the periodic table in 1869, organizing elements by their atomic weight and predicting the existence of undiscovered elements. John Dalton proposed the atomic theory, stating that all matter is made of atoms, which combine in fixed ratios to form compounds. Marie Curie discovered radioactive elements, and Avogadro proposed the concept of the mole, laying the foundation for physical chemistry. 20th century and beyond. The 20th century brought further breakthroughs in understanding atomic structure and chemical bonding. Quantum mechanics and Einstein's work on energy and matter shaped modern chemistry, particularly in the study of atoms and molecules. The discovery of polymers, synthetic materials, and the development of biochemistry, chemistry of living systems, have had lasting impacts on both industry and medicine. Top chemicals and discoveries in chemistry. Oxygen, O, discovered by Joseph Priestley and Carl Wilhelm Scheele. Oxygen is one of the most essential elements for life and combustion. Lavoisier named it and described its role in combustion and respiration. Hydrogen, H, the lightest and most abundant element in the universe. Hydrogen plays a crucial role in chemical reactions and energy. It was named by Lavoisier and is central to the formation of water, HO. Water, hydrogen oxide. Water is often considered the universal solvent due to its ability to dissolve many substances. Its importance spans biology, chemistry, and environmental science. Carbon, C, the backbone of organic chemistry. Carbon forms the basis of all life on Earth. The study of carbon compounds, from simple molecules like carbon dioxide, CO, to complex proteins and DNA, is essential to biology, medicine, and materials science. Sulfuric acid, hydrogen sulfate, known as the king of chemicals. Sulfuric acid is one of the most important industrial chemicals, used in everything from fertilizer production to oil refining and wastewater treatment. Ammonia, NH, crucial for agriculture. Ammonia is used in fertilizers that help grow food for billions of people. The Haber-Bosch process for synthesizing ammonia was a major chemical breakthrough of the 20th century. Sodium chloride, commonly known as salt. This compound is essential for human health and food preservation. It has been used for millennia in cooking and in preserving food. Methane, carbon tetrahydride, the simplest hydrocarbon and a key natural gas. Methane is a primary source of fuel and energy. It's also a potent greenhouse gas, making it important in discussions about climate change. Nitroglycerin, CH trinitrogen monoxide, a powerful explosive and vasodilator. Nitroglycerin has been used in both medicine and dynamite, discovered by Alfred Nobel. Aspirin, C hydrogen oxide, one of the most widely used medications in history. Aspirin is used as a pain reliever, anti-inflammatory, and blood thinner. Its active ingredient, salicylic acid, was originally derived from willow bark. Polymers, the discovery and development of synthetic polymers like nylon, Teflon, and polyethylene revolutionized the material sciences. These compounds are used in everything from clothing to packaging and have reshaped modern manufacturing. DNA, the discovery of the structure of DNA, deoxyribonucleic acid, by Watson and Crick in 1953 marked a turning point in biochemistry and molecular biology. DNA is the chemical basis for heredity and genetic information. Penicillin, discovered by Alexander Fleming in 1928, penicillin was the first antibiotic, revolutionizing medicine by providing an effective treatment for bacterial infections. Silicon, C, the key element in the production of semiconductors. Silicon is central to the technology that powers the modern digital world. It's used in everything from computer chips to solar panels. Chlorofluorocarbons, CFCs, once widely used in refrigeration and aerosol sprays, CFCs were discovered to be harmful to the ozone layer, leading to their phase-out under the Montreal Protocol. Graphene, a one-atom thick layer of carbon atoms arranged in a hexagonal lattice. Graphene is an incredibly strong and lightweight material with unique electrical and mechanical properties, with potential applications in nanotechnology, electronics, and materials science. Conclusion: chemistry has evolved from early experiments in alchemy to a rigorous science that underpins much of our modern world. The top chemicals and discoveries have transformed industries, improved health, and expanded our understanding of the universe. Chemistry continues to be a dynamic and essential field, shaping the future of technology, medicine, and environmental solutions.